Welcome to the Explainer. Today, we're going to decode a technology that is completely turning AI language generation on its head. For years, AI has basically written text like a very careful typist, just one word at a time. But what if it could think more like a painter, creating the entire picture all at once? Let's dive in and see how. And this quote from AI researcher Andrej Karpathy just hits the nail on the head. We need to forget everything we know about that familiar left-to-right sentence building. Diffusion models do something that is, just fundamentally different. They start with total chaos, pure noise, and then they sculpt an entire piece of text right out of it, all at the same time. This visual just lays it out so perfectly. Over on the left, you've got the traditional method, what they call autoregressive. Yeah, it's exactly like that typewriter, just clunking along, one word after the next. But on the right, that's diffusion. That's way more like watching a sculpture emerge from a block of marble. The entire shape is there from the beginning, it just gets more and more refined.
And this gets us to the really big question, the one that challenges decades of assumptions in this field. Why do we have to generate text one word at a time? Sure, it's how we speak and write as humans, but is it really the absolute best way for a machine to put together a thought?
All right, so to answer that, we're going to frame this whole thing as a tale of two models. We're going to look at the old, established way of doing things and put it right up against this powerful new contender. But here's the twist. To really, truly understand how diffusion works for text, we first have to take a little detour. We've got to look at where it's already a proven master, the world of image generation. Seriously, the ideas we're about to see there, they are the key to unlocking its power for language. Okay, so how does this actually work with pictures? Well, think of it like a two-step dance. First, you have to teach the AI. You do this by taking a perfect image and just wrecking it. You slowly add noise, kind of like TV static, until it's totally unrecognizable. The AI's job is to watch you do this and memorize exactly how you destroyed the image, step by step. And then comes the magic trick. You give the AI a screen of pure, random static. And because it learned how to add the noise, it now knows how to run the process in reverse. It subtracts the noise, bit by bit, until a brand new, totally unique image just appears out of thin air. Now, to really get what's happening here, we need a bit of a mental shift. I want you to stop thinking of an image as just a file on your computer. Instead, imagine it's a single point on a gigantic, invisible map. This little conceptual leap is where you start to see the true power of diffusion. And we call this map pixel space. Think of it like this enormous library where every single image that could possibly exist has its own unique spot. That includes a perfect photo of a cat, but it also includes every possible combination of random static. For just a tiny 128 by 128 image, that map has over 16,000 different directions or dimensions. It is just impossibly vast. So that leads us to a really important question. In this nearly infinite space of every pixel combination you can imagine, where do the images that actually look like something, a face, a car, a landscape, where do they actually live? Well, the answer is kind of mind-blowing. The vast, vast majority of that pixel space is just garbage. It's random pixels that look like TV static. The points that represent things we would actually recognize as an image are all clustered together in one tiny, specific little neighborhood inside that endless space. And that small, concentrated cloud of real images, that's the treasure map. Now, the experts call this a probability distribution, but you can just think of it as the zone of stuff that makes sense. The entire goal of a generative AI is to learn the exact shape of that map, so it can generate new things by picking new spots inside that real zone. Okay, so we've seen how this works for images, right? It's a pretty powerful idea. Now, let's take that concept and bring it all back home to the world of language. How do we give text that same generative power? The amazing thing is, the analogy holds up almost perfectly. For images, we have pixel space. So for text, we can imagine a token space, where a token is just a word or a piece of a word. And just like most pixel combinations are just static, most combinations of words are complete gobbledygook. The AI is on the hunt for that tiny little cloud of meaningful sentences. So here's the crucial takeaway. The whole point of a diffusion model is to find that underlying probability distribution, that treasure map of real data. And that goal isn't specific to images at all. It's a universal principle for generation, whether you're creating a picture or a paragraph. All right, now for the part you've probably been waiting for. We've got the theory down, but so what? Why does this actually change everything? What are the real world advantages of generating text this new way? Let's just quickly check back in with the old way, autoregressive models, or ARMs. They basically work like a chain reaction, predicting the next word based only on the words that came before it. This one-at-a-time process creates a huge bottleneck, and it makes generation super slow. It's kind of like trying to drive forward while only looking in the rearview mirror. It really struggles to see the big picture.
And when you put them side by side, the difference is just crystal clear. Autoregressive is sequential. Diffusion is parallel. This creates a massive gap in what's called inference speed, which is really just how long it takes the AI to come up with a response. One is a traffic jam, the other is a wide open highway.
Let's make this totally concrete. To go from pure noise to a finished sentence, a diffusion model might only need, say, 14 refinement steps. Just 14. Now, how many steps does it take the old method to write that same sentence? 75. 75 steps. I mean, come on, that is a massive difference. We are not talking about a tiny little tweak here. This is a fundamental leap in efficiency. It's a total game changer. And so, this leaves us with one final and, I think, pretty fascinating question. This shift isn't just about making things faster. If an AI can compose an entire paragraph all at once, thinking about the whole structure from the very beginning, instead of just what word comes next, what does that unlock? It's a whole new way of thinking for machines, and we're just beginning to see its full potential emerge from the noise.